How many unique 4-digit numbers can possibly be formed from the digits 1, 2, 3, and 3? One approach is to list out all the possibilities. That number is not so crazy that you couldn't do it on paper, which I've taken the time to do here below, but it is long enough that, given an average time of 1.5 minutes per question, it is pushing the limits and gets pretty crazy. But I've done this to prove a point and show how we can learn to solve these problems a little more quickly. I've taken the luxury of taking the last 3 and calling it B instead of 3 for a moment, as if we had 4 different or unique digits, which is not the case here, as we know. So if I did that, I would have 24, 6 times 4 is 24 different arrangements of the 4 digits. Now, one way to think about that is my first digit choice. I can choose either a 1, a 2, a 3, or a B. So I have 4 ways to choose the first digit. Then, when we come to the second digit, I have 3 ways to choose, given that I chose my first digit. So, in the case that I chose 1, I can choose 2, 3, or B from my remaining digits. And likewise, once I've chosen 1 and 2, my first 2 digits, there are only 2 possibilities left, 3B or B3, given that I've chosen 1 and 2 already. If I chose 1 and 3, it would be 2B and B2 left, 2 more. And same if I had chosen 1 and B. So what I essentially have here is 4 choices for my first digit times 3 choices for my second digit, and you can see each one of the 4 is multiplied by the 3 options for the second digit, times 2 choices for the third digit, and of course then there's only 1 digit left and my decision is made for me. This is otherwise known as 4 factorial. And in general, n factorial is the way n objects that are unique can be arranged. We have eliminated the need to list out all 24 possibilities if we simply know 4 unique digits can be arranged in 4 factorial ways, which is 24. That is not quite the answer to our problem, because we have to revisit my first assumption, or fudge in this case, to bring out an important point for you to take note. We repeat a digit 3. It is not a separate or unique digit B, as I call it here temporarily. It is a 3. So in fact, when we have 1, 2, 3, B, it really is the same as 1, 2, B, 3. So we've double counted, or over counted in this case. Those 2 are really the same. In this case over here, just to pick another one, is we have 3, 2, B, 1. Well, we really know the B is a 3, so if we actually had a B, 2, 3, 1, which we do, right next to it, B, 2, 3, 1, that is really the same too, because the 3's and the B's are really all just 3's. So you're starting to see a pattern. We've double counted in this case, and the way we can assess our overcounting is we actually took 2 objects, which, as we learned before, can be arranged 2 times 1 or 2 factorial ways if they were unique objects, but they're not. So we need to reduce or divide by the number of ways we can arrange the figures that repeated. In this case, 2 factorial. So our result becomes 4 factorial divided by 2 factorial, which is essentially 24 for 4 factorial, 4 times 3 times 2 times 1, divided by 2. The answer is there are 12 ways to arrange 4-digit numbers when 2 of those digits repeat. And hopefully you could see that out of our 24, we really only had 12 unique figures.